In this video, we're going to be talking about line segments instead of lines. So let's review quickly what a line segment is. It is a portion of a line that has two endpoints. Since it has two endpoints, it can be measured, and you name it using those two endpoints with a bar above the two endpoints without arrows over the top. So in this example, I have line segment ST, and I can name that either capital ST with a bar over it or capital TS with a bar over it. And I would read that line segment ST or line segment TS. Order does not matter. Now when you're talking about the length of a line segment, the notation that you use for that is that you leave that little bar off of your two endpoints. So in this example, line segment AB, where I have an A and a B with a bar over it, you would read that line segment AB. But if I left that bar off and I just wrote the capital letters AB, I would read that the length of line segment AB. I need you to put a big star by this in your notes, because this is a very important notation and distinction that I will be testing you over. Now, if at any time I'm going too fast, please pause the video. Go back, listen to what you need. All right, now you're going to hear some terms. One of them is called a postulate. Another one's called an axiom. I'm not sure that we ever use that, but I need you to be aware of it. What those are is a term that just means the rules of geometry that are accepted without proof. They're kind of like, well, duh type rules. One of them is the ruler postulate. And it says that if I have a line segment and I match that up with a number line, something like a ruler, that the distance or the absolute value difference between the two endpoints of that line segment is the length of my line segment. So if I take this example, I have line segment ST and I've matched it up with this ruler. I have one point at 2 and one endpoint at 5.4. Well, if I subtracted those two endpoints, the absolute value, because it's never distance is never negative, is 3.4. So the length of that line segment is 3.4. Now I need to put a big star by this next vocabulary term. It is called the segment addition postulate. Now before you write anything down, I want you to just kind of listen to this. If I have a line segment and I cut it into two pieces, if I add up the length of those two pieces, I will get the length of the whole piece. That is what the gist of the line segment postulate means. So on a line segment, if point B is between the endpoints A and C, then the length of line segment AB plus the length of line segment BC would have to equal the whole line segment, which is the length of line segment AC. So pause your video and write down this example in your notes. You have this line segment AC and you've put a point in the middle of it, so it's broken the line segment into two pieces, AB and BC. So if I add those two pieces together, I have to get the whole line segment. Now I have another example if you want something very concrete with numbers. I'll do this one really quick for you. I have a line segment RT and I have S in the middle. So if I know that RS is 7 and I know that ST is 4, then those two pieces together, if I add them, would give me the total length of RT, which is 7 plus 4 or 11. Okay, now this is another vocab term I need you to put a star by because you're going to use it over and over and over and over and over. In geometry, it's called congruence. In geometry, if shapes have the same measurements, we refer to them as being congruent. And we actually have a symbol that means that. This equal sign with a little squiggly above it, you would read that congruence. For a line segment, to show that two line segments are congruent, you're going to use a little hash mark. Sometimes I call it a ticky mark. And that would be this little line here and here. Those are hash marks. And it shows that line segment AM is congruent to line segment MB. Now, midpoint is another kind of important term, and that is the point that divides a line segment into two congruent segments. So it's not just two segments, it's two congruent segments. That means they have the same measure. Now be careful, be careful, be careful here. Just because a point is in between two other points does not make it a midpoint. The only way you know it's a midpoint is if you have these hash marks that tell you that the two line segments are congruent. Now, again, write this example down because this is very important here. I'm going to read that point M is the midpoint of line segment AB. So, line segment AM is congruent to line segment MB. And the length of line segment AM is equal to the length of line segment MB. Now that's a very important distinction because in the first one, line segment AM is congruent to line segment MB. We're talking about the figure, the actual two lines, the figures. But when we're talking about the length of line segment AM and the length of line segment MB, we're talking about measurement, so we must use an equal sign. Okay, now we are going to be doing a thing called constructions, and a construction is a geometric drawing that uses a limited set of tools. And in the past, it's always been a compass and a straight edge. Well, that was kind of in the dark ages. We will be doing almost all of our constructions using a software tool called GeoGebra, which is already on your MacBooks. Now, we will probably do one that's using a compass and a straight edge, so you can kind of get the feel of that, but most of ours will be on GeoGebra. So let's skip to the practice, and let's practice this. I've given you a line segment here, RT, with a point S in between R and T, the two endpoints. Now, let's label what they've given us. They've said that the length of line segment ST is 20. The length of line segment RT, which is the whole thing, is 57, and they want us to find the length of line segment RS. So we've got two parts, RS and ST, and we've got one whole, RT. And we know that the whole RT has to equal the sum of the two parts. So I've actually written that down, and I would highly encourage you to do this on your homework. And then you're just going to plug in the things that you know. You know that RT is 57. You know that RS, let's just call it X because we don't know what it is. And we know that ST is 20. Now this is a one-step equation. You know how to solve. So do so, and you're going to find that X is 37. So the length of line segment RS is 37. Remember, parts add together to give you the whole. That is called the segment addition postulate. That's what we just used. Here is another example. I've got line segment RT with an S in the middle, and I know that the length of line segment RS is 3x plus 2. We're going to kick it up a notch here. And that the length of line segment ST is 3x plus 9. And the length of the entire line segment is 12x minus 7. Again, I know that the whole line segment has to equal the two parts added together. So I'm just going to plug in the things that I know, just like I did on the last one, that 12x minus 7 equals 3x plus 2 plus 3x plus 9. Now, this is a little more complex, but you know how to do this. It's an algebraic expression. We've got some like terms that we're going to combine. So I've got 12x minus 7 equals 6x, because 3x and 3x equals 6x. And we've got some other like terms, which are our constants, so plus 11. Now I have an equation with variables on both sides. I can't have that, so I'm going to move my smaller variable, and I'm going to solve this equation. And when I do, I get that x equals 3. Now, as soon as I find that x equals 3, I can plug that 3 back in for x in these expressions and find the length of each line. So RS, if I put 3 in for x, the length of line segment RS is 11. The length of line segment ST, if I put 3 in for x, is 18. And line segment RT I can find in one of two ways. I can either plug the 3 in, or I can just add up the two segments, 11 and 18, and I get that the line segment, or the length of line segment RT is 29. All right, our last example. I have a line segment here, PQ, with T, which is the midpoint. So T is between PQ in a very particular way. It exactly cuts PQ into two congruent segments. And I know that by looking at these two hash marks. And also they tell me that. All right, so let's label what we know. We know that those two segments equal each other. And we know that the length of line segment PT is 4x minus 8. The length of line segment TQ is 2x plus 2. And I know those two have to equal each other, so I'm just going to plug those into my equations. Again, I have variables on both sides, which I can't have. So I'm going to move my smaller variable, and then I have a two-step equation I know how to solve. And when I do, I get that x equals 5. As soon as I find that x equals 5, I can plug that back into the expression for PT, the length of line segment PT, sorry. And I get that the length of line segment PT is 12. All right, now again, we went through this very quickly, but I think you have what you need for your teacher talk and your practice.